queue is something like this. Here you have someone who is, let's say, distributing sweets, and then this is the queue of people who will come and he will give the sweet and the people will go out. So the flow is in this manner, means that anyone that will come into the queue will be coming from this end, and the one who is going out will be taking the sweet and going out in this end. So you have two different ends, and where insertion is happening from one end and deletion is happening from the other end. If we have to insert something, it will only be inserted here. So it's like when you go, you can't go at the front. People will call you, hey, go back to the queue. Okay, because insertion has to go from that side. And once he gets the sweet, he will go out. So in this manner, what happens is that it behaves like a FIFO. It behaves like a FIFO, means whoever first in, he will be first out. Because this man would have been inserted before this and this, so he will come out first. Okay, so in a queue, in the stack, what happens? One end is fixed. Whatever happens was from the top. So whatever was inserted last, that will only be taken out. And so we said last in, first out. But in case of queue, the order in which the objects are inserted, that is the order in which they are coming out also, or they are removed also, or they are deleted also. So linear data structure such that insertion takes place from one side and deletion takes place from other side, making it like FIFO. Now the side at which the insertion is taking place, that we call it as rear side. So here, this is your rear side. This is your rear side and this is your front side, because the side from which deletion takes place from other side, and this is your front side. Okay. Now if we want to implement this type of structure using an array, so in queue, the insertion operation is called enqueue and this deletion operation is called dequeue. And deletion operation is called as dequeue. Okay. So enqueue means the element at the rear end, you will add one more element. Enqueue means at the rear end you will add one more element, and dequeue means the element at the front will be removed. Now let's look at how this queue can be implemented using an array. So initially, when your queue is empty, so we have two variables we set as front and rear, okay, which at any point of time will have the index of the array. So it suggests that what is the front of the queue, means the index that is at the front of the queue, and the index at the rear end of the queue, means if you have to insert something, you have to insert from the rear side. So for example, at any point of time, if your queue is filled, this is filled, let's say 2, 3, 4, 5, if your insertion is happening at this end, means this is the direction of your queue. Direction of queue is this, means insertion will happen from here. This is how it will go. So if at any point of time, the last element, that is where the rear is pointing to, and the first element is that is where front is pointing to. Not pointing to, sorry, this is not a pointer, it holds the index value, okay? So if you want to insert an element, what you will do, you will insert at index 4, and let's say you want to insert 8, then 8 will be inserted, and now rear will have the value 4 again. Okay, my convention is that the front is at the beginning of the array and rear is as you go towards that side, that is rear, means you will add from there and it will come out from there. Now Let's not disturb this. Let's make a fresh array. Let's keep it clean because we will see many cases. So initially when your queue is empty, the front and rear both is set as -1. Okay. So front is equal to rear equals to -1 means your queue is empty. Now when you, let's say you add an element to it, you perform an enqueue operation. So when you perform an enqueue operation, what happens is, this is your enqueue operation. Enqueue means adding an element to the queue. So this is what you have to check, that if you have to add an element, your queue must not already be full. Okay. So if your queue was full, let's say this is your queue and it is full, something, it is full, then rear is pointing to, not pointing to, the rear has the index of last element. It means if rear is not equal to n-1, means at least you know that, okay, you have one element that is empty, one place in the queue where you can add an element. So if rear not equal to n-1, then you can add the element. Okay, you increase the rear value by 1 and then to that place you insert x. To into x, this is what it is. So you can say that when rear is equal to n-1, then your queue is full. Rear equal n-1 means queue is full. Queue is full. Okay? No. That's not right. Queue is full when rear is n-1 and front is equal to 0. Then your queue is full. Okay. Then what we are actually checking here? We are checking if we can fill in the queue or not. Means your queue may be your queue may have places that is empty, but you can only add element from the rear end, and to add an element from a rear end, this slot has to be at least for your surety that you can add an element. It will not go beyond the memory allotted. Then for that you must be sure that at least your rear should point to n-2. Okay, anything less than n-2 all is fine, but if rear is already at n-1, then you cannot add any element. Now you may be thinking, that what is this? Queue is full when front is 0. Okay, can it happen that front is not 0 and rear is at n-1? Yes, it can happen. Why? Because you can delete elements. You can delete elements from the front side. And what happens when you delete elements from the front side? See this. This is your queue. Okay, and you keep on adding elements 1, 5, 8, 6, 4. Okay, and let's say this is the size of your array, for example. Okay, so where the front is this, and this is rear right now. Okay, and it may happen that you delete an element. So the moment you delete one from the array, now your front is here. Okay, again if you delete an element, your front is here. Again if you delete an element, your front is here. Again if you delete an element, now your front is here. And now again your front and rear becomes equal. So you can see that if front is equal to rear is equal to k, So there are three cases I have taken when front and rear becomes equal. One is when they are -1, it means the queue is empty. The another one is when front is equal to rear is equal to 0, it means your queue has only one element, and that is at the beginning of the element. So when at very first time when your queue is empty and you add an element, here your element will be added in front and rear both will be pointing to, not pointing again, I'm sorry, both will have the index of this. Now in this case also, where front is equal to rear is equal to k, q has only one element and add the index k. Okay, so q is full when the q is full, when rear is n-1 and front is equal to 0. Okay, so we have seen the Enqueue operation. So while in the Enqueue operation, when you can add an array, when you can add an element, you can add an element if rear is not pointing. You can add an element if rear is not, the index, the value of rear is not the last index. Okay, last index of array. Then you can add an element to the. And when you have to dequeue, when you have to dequeue, means that you have to remove an element of the array. Okay, before you dequeue an element, before I explain how to dequeue an element, just see that at any point of time, what is the front and rear? At any point of time, what a front and rear could be like. Let's say this is your array. At any point of time, you may start adding an element. Okay, so 8, 6, 3, 5, 12, 15, 4. So your front is here and your rear is here. Now you may delete elements, so your front will increase, will come here, right? So at any point of time, you see the elements are between front and rear only. At any point of time, the elements are between front and rear. Whether if your front is here, means the elements are between these two. Means if front is equal to f is 0 and r is 0, 1, 2, 3, 4, 5, 6, r is 6, means the elements are between 0 and 6. If you add one more element, and let's say it is 19, and rear is now 7, then the elements of the queue is from 0 to 7. If you delete an element from your queue, you delete 4, you delete 15, you delete 12. Okay, now front is 3. Now f is equal to 3. So the elements in the queue is from 3 to 7. Okay, you can keep on deleting, and then your front will be at 7 and your rear will be at 7. So again, the elements are between index 7 and 7, which is only one element. Okay, so it will always be the case that your front is less than equal to r. Okay, because you can only add at the rear end and you can only delete from the front end. Because of this, f is always less than equal to r. Okay. Now, if f is less than r, it means your number of elements is greater than 1. F is less than r means either your front is here, or 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 your front is here. So the number of elements is greater than 1 in your queue. And if f is equal to r, then if it is not -1, means you have one element, and if it is -1, means the queue is empty. Okay, so whenever you have to dequeue an element, dequeue means removing an element from the queue. First, what you will check, that is your queue not empty or not? Because if your queue is empty already, what elements are you deleting? You cannot delete from an empty queue. So if your element is not, if your queue is not empty and front is not equal to rear, so you can say front not equal to rear. You can also say front is less than rear, because that's the only scenario. front is less than or equal to R, so you can write here front. If I want that front and rear are not equal, means F is front is less than rear, then front plus plus. Because now if front is not equal to rear, I means there are more than one element, and you can very easily you can delete that element, means that your front will be incremented. Okay, and if what if you have just one element in the queue? What if you have just one element in the queue? Then you have to make, because deleting this element will mean what? Will mean that now your queue is empty. So you have to make your front and rear both as -1 if you have front equal to rear, because front equal to rear means that you have either your queue is empty or your queue is having only one element, but we have already checked. We have already made that sure that if queue is not empty and front is equal to rear, then means now after removing the queue will become empty. So set front and rear as minus. Okay. So this is about linear, not circular queue. In the next video, we will see that because of the linear queue, there are spaces in the array, but we cannot add an element, and so a circular queue comes to the rescue. In the circular queue, we can add elements to the size of the array, but in linear queue, the worst possible case is that look at this. What if your front is equal to rear and this is equal to n-1? It means what? It means that you have only one element, and that is here. Now you have all these places, all these cells of array empty, nothing is there. And you want to add an element, you can't add because rear is already here. You cannot increase rear and add an element. So this is the drawback of linear queue, that you may have spaces, but because rear is already at the extreme end, you cannot add element, because you can only add element from rear side. So circular queue comes to the rescue. How? Circular queue will go this manner. So in circular queue, if rear will go again, start from here. So that we will see in the next video. Thank you.